We're about to watch section 8.3, Solving Right Triangles. The objective of this lesson is to use trigonometric ratios to find angle measures in right triangles and to solve real-world problems. First, here's a reminder of what we covered in the last section, the trig function sine, cosine, and tangent, which we're using with the right triangle to find a missing side. We learned that the sine of an angle, and specifically angle A here, the sine of angle A is equal to the ratio of the opposite leg length to the hypotenuse length. Cosine is adjacent over hypotenuse, and the tangent is the opposite over adjacent. And we were using these to find the missing side of a right triangle when we're given one of the acute angles. Today we're going to learn about inverse trig functions. And instead of looking for our missing side, we're going to be looking for the actual angle measures. Our inverse trig functions are sine inverse, cosine inverse, and tangent inverse. So we're going to be finding the angle rather than a missing side. To work with the inverse trig functions, we're still going to use SOHCAHTOA to help us determine which function to use. Make sure that you remember when we're using our calculator, we must put it in degree mode. So I'm going to go ahead and do that right now. Go to my mode button, go down to my angle row, and set it to degree. Now I'm ready to get started. Notice in the inverse trig functions, you don't only just have sine, you have sine to the negative 1 power. We read that as the sine inverse, and that relates to the button on the calculator. Right above the sine key, you can see the sine and the inverse symbol. So to use that function, we'll hit the second and then the sine button. And then here is where we'll put the ratio of those two sides, the opposite over the hypotenuse. And what we'll end up with is the angle with which the sine is that value. Let's get some practice using it. In the first example, we're going to use our calculator to find each angle measure to the nearest degree. So looking at the first one, we are looking for the angle whose tangent is 0.75. So to find the angle, we're going to use the tangent inverse. Let's pull up the calculator. So if I want to know the angle whose tangent is 0.75, I'm going to second tangent 0.75, get 36.869. We're wanting to put our answer to the nearest degree, so the angle would be approximately 37 degrees. Okay, for the next one, the angle whose cosine is 0.05. Second cosine, 0.05. That angle must be approximately 87 degrees. And the angle whose sine is 0.67, we end up with an angle of 42 degrees. For the second example, we're going to use the calculator to help find the measure of the indicated angle. So we're looking for this angle, calling it x. So based on this angle, I have the opposite side, and I have the hypotenuse to work with. Okay, remember, SOHCAHTOA helps us determine which trig function I'm going to use. So since I'm using opposite and hypotenuse, I'm going to be using the sine function. But because I'm looking for the angle measure and not one of the sides, I'm going to use the inverse sine function. So I'm going to say the sine inverse of the opposite over hypotenuse. Whatever that ratio is, that's going to give me the measure of that angle. Okay, so in this case, that is 3 over 5.8 And then I just use my calculator. On an inverse, 3 over 5.8. And I find that angle must be 31.147. We're going to go ahead and round it to the nearest degree. So our angle is approximately 31 degrees. Now that I know x, I could subtract it from 90 to find the other acute angle, which would be 59 degrees if I needed that angle as well. Okay, that's not too bad. Let's hit the next example. For example 3, we're going to find the unknown measures of this right triangle. We're going to round length to the nearest 100 and the angle measures to the nearest degree. But we start out with two sides or even one side and one of the acute angles, and we want to find all of the other measures. That's called solving the right triangle. So in this example, we're going to solve this right triangle. I'm just going to pick a place to start, and I'm going to start with angle x. And using angle x, I see that I have my opposite side is 11 units, and my adjacent side is 8.6 units. So remember, SOHCAHTOA tells us that if you're using opposite and adjacent, we'll be using the tangent function. But since I'm looking for my angle measure, I'm going to use the tangent inverse. So I want to know the angle whose tangent is 11 over 8.6. And that will give me the measure of angle x. Okay, so using my calculator, the second tangent, 11 over 8.6. And I find the angle measure is about 52 degrees. Now, we were told to leave the angles to the nearest degree, and I'm going to do that in my final answer. But if I have to use this angle in another calculation, then I want to make sure that I don't have a lot of rounding error. So if I give myself a few extra decimal points, then I have less chance of that. Now I can find out angle z, because I know the two acute angles of a right triangle add up to 90 degrees. So the measure of angle z would be 90 minus 51. So that would be approximately 38 degrees. And now I can find that third side. So in this case, you can use a couple of different ways. We know two sides of a right triangle, so we could use Pythagorean theorem to find that third side. But I'm going to go ahead and use the trig function since we've been working with trig, and I think it's faster. So if I'm looking for the hypotenuse, which is my last side to find, then I'm going to pick a trig function that uses the opposite or adjacent and the hypotenuse. So I'm just going to go with cosine. The cosine, and here's where I'm going to use my angle. I'm going to say the cosine of this angle, angle x, is the adjacent over the hypotenuse. Since I rounded, that 52 degrees is rounded, I'm going to use what I came up with initially. So the cosine of 51.981 degrees. That's going to equal the adjacent, 8.6, over the hypotenuse, which is xz. So to solve that, I'm going to get xz by itself, multiply it on both sides, then I'll divide by the cosine of 51.981, and I end up with xz is equal to 8.6 divided by the cosine of 51.981 degrees. Then I use my calculator. Now, when I'm looking for an angle, I use the inverse trig function. When I'm looking for the side, I use the standard trig functions. And I get 8.6 divided by the cosine, 51.981. And I find that xz is approximately 13.96 units. So my final answers are: measure of angle x is 52, angle z is 38 degrees, and the side FC is 13.96 units long. Okay, in the last example, we have a highway sign that warns that a section of the road ahead has 11% grade. To the nearest degree, what angle does that road make with a horizontal line? Okay, when we're talking about the grade of a road, it tells us how much that road rises over a certain distance. So the best way to start is we're going to take that 11% grade and we're going to write it as a fraction. We have 11 over 100. So this grade tells us that that road rises 11 units, so let's just say 11 feet every 100 feet. So really we have kind of the slope of the road. We have the rise over the run. Rise is 11 feet every 100 feet horizontally. We're going to use the right triangle to represent this problem. And since the grade is 11 degrees, I know that it rises 11 feet for every 100 feet horizontally. And I'm asked to find the angle the road makes with the horizontal line. So if this is my road, I want to know what is this angle here. So remember, when we're trying to find angles, we're going to use our inverse trig functions. You need to make sure you have your SOHCAHTOA in front of you. And if this is my angle, then I'm going to be using the opposite side and the adjacent side. So that would be the tangent. So I'm going to say the inverse tangent of 11 opposite over adjacent, 100, will give me the measure of my angle. Type it in. Inverse tangent of 11 over 100 is about 6.2. So that angle is going to be about 6 degrees with the horizontal. Okay, that's all we're going to do for today. If you'd like to see some other examples, please go to your textbook, page 534 through 537. And you can also go to the online textbook where there are some more videos covering some more examples that you can watch. If you have any questions, please bring them to class tomorrow, and we will go over them at that time. See you then.